Hi, thanks for tuning in on this presentation on reverse return systems. So, why install a reverse return system? The system is balanced by design. It can be useful for cascading boilers. It can be useful for cascading cylinders. Therefore, the aim of this presentation is to show you a standard two-pipe system, lock shields and TRVs / conventional balancing, show you a one-pipe, show and explain the reverse return system, show other places it can be installed, tips for installing it. So a standard two-pipe system. This is a standard two-pipe system. Okay, so we've got a boiler and it's coming off on the flow there on the red, and it goes into the first radiator. So it's got the shortest flow and then the longest return back to the and the shortest return back to the boiler. So all energy will always take the easiest path of less and the path of less resistance. So it's going to whiz around radiator 1 all day, and it's going to prioritize that. Okay, and then the second radiator and the third radiator. So that's a standard type of system. So it could have the longest flow and longest return. Okay, so lock shields, TRV. These are your lock shields. So the lock shield is here. Okay, and this is like mini zoning for the house. So you set these to the output you want. Like number 3 is 18 degrees, for example. Quite handy for bedrooms and the rest of it. And then on the other side of the radiator, you usually have what's called lock shield. And the lock shield is used for balancing the system. What it does in effect is cause resistance on the one side of the radiator. So you're trying to equalize all the resistance throughout the system. So the longer pipe runs have got less resistance than the shorter pipe runs, so the system heats up equally and balanced. So the better the valve, the more authority it has. So an example of this is your first radiator there. We put a quarter turn opened from close. So we close the valve down fully all the way, open it up a quarter turn. The next radiator, maybe you'd open it up half a turn, and then the third radiator a quarter turn, and so on. It's usually quite fine movement. You're not really getting to half a turn and quarter turn. It's just sort of to illustrate that the first radiator will be choked down a lot more than the last radiator on this system. Okay, so we're looking for the system to heat up equally and the water to flow around the system equally. So we're not having one radiator get hot super quick and the other one takes an absolute age to get hot. Okay, so the one pipe system. Right, one pipe systems you tend to see in older properties, and what you do is it goes out of the flow and it goes on one great big giant loop around the property and then returns to the boiler, and the only thing that allows the radiators to get hot is natural convection. All of the radiators heat up at random times. It's a bit of a nightmare to balance them because you've got to sort of balance them so they to be honest, I don't even know how to balance a one pipe. They're just a nightmare. Yeah. So if you have a one pipe, keep calm and bin it. Just get rid of it. It's not going to work on a condensing boiler. Okay, so show and explain the reverse return system. So here's a reverse return system. Comes out of the boiler, goes into the first radiator, so it's got the shortest flow. Then the return pipework comes out of that radiator and it returns the longest length back to the boiler. So the first radiator has shortest flow, longest return. The midpoint radiator in the system has equal amounts of both, so it's equal amount of flow, equal amount of return. And then the last radiators on the system has the longest flow and shortest return. So it's inherently balanced just by design. Your boilers on a modern condensing gas boiler, oil boiler, coming out at 70 degrees, the boiler software is trying to make that boiler condense as much as possible. So if the flow is returning, for example, if it was on a one pipe, it's going to be returning way too hot. It's probably going to be a very small delta. So the boiler's there at that point, it's going to start modulating down. It's trying to achieve a 20-degree difference between the flow and return. So all the boilers these days have modulating pumps which are burner linked. So it's going to start choking that down. So you can see why one pipe is, first of all, is not really going to work on a condensing boiler, because the boiler is going to be getting mixed signals from the thermistors on the pipework, and the radiators are not probably going to have enough heat to start getting the heat up, and it's not going to condense very well at all. I think you lose 60% efficiency on a one pipe. They're really, really bad for efficiency. Okay, so reverse return systems, they're they're not a new thing. They've been around for ages. They're in a domestic heating design guide. So if you go to page 68 of that, 13.3 for the actual chapter or heading, it'll just show you reverse return systems in there. So other places it can be installed. So it's quite a handy setup really once you get your head around them. So if you had 2 cylinders, I've had this on a job, we've got 2 smallish cylinders in a tight area, but they were both 150 litre cylinders, but they needed 300 for the property due to the amount of bathrooms and the requirements of it. So they had 2 cylinders together, and they weren't piped like this first of all, so we ended up changing them. So it comes out your boiler, you've got the shortest flow, longest return back to the boiler to heat it through the coils, and then we've even cascaded the cold in. So we've come into the cold, got shortest cold in, longest hot out of the one cylinder, and then longest cold in, shortest hot out of the other. So they should be drawing off at exactly the same time, and the coils are getting exactly the same heat load in, which is balanced from the boiler itself. Cascading cylinders, really handy if you've got a property with a big heat loss, like I don't know, maybe 6-7 bedroom house, and you've got 2 boilers cascaded together via a low loss header, or probably wouldn't use a close couple of tea. You would put a double boiler, you'd put a low loss header on. It's a bit of a better job on that sense. So you could cascade 2 of those boilers into your low loss header for your separation, and then go off onto your system then. So as you can see, this boiler here has the longest flow, and then it's got the shortest return back. This boiler has the shortest flow and has the longest return back to the boiler. So the boilers can work together to load this low loss header, and they're going to be equally balanced pumping into it. Alright, so my tips for installing it on this heating system. So first of all, run your flow to your first radiator as normal from the boiler. So just run the flow pipe. Once you get to that first radiator, tie in the return to the first radiator, and then you're pretty much, it feels like you're on a standard system after that. So run the system as normal all the way to the last radiator on that system. Complete the flow into the last radiator, so end it there, and then run the return back to the boiler, and that's your reverse return going in. They can be a bit, some people struggle with them. I find that's the easiest way to do it. Just get it to a normal system as quick as you can, in the sense of, you know, flow return after radiator 2, 3, 4, 5, 6 and so on, and then the last one just remember to tie into the actual the flow, and then run the return back to the boiler. Okay, so thanks for listening, and tune in next time for more bits and bobs. Thanks, bye.